What the system does is it tracks vehicles as they travel along the highway, generates traffic flow statistics, determines where incidents are occurring, determines what type of incident is occurring, whether it's an actual traffic incident, whether it's just a traffic jam. Then it reconstructs that incident by using a highly accurate tracking process that's called optical flow to then produce a video reconstruction of the accident and provide that to operators. So the main problem today is helping these guys in a data center with 105 cameras that for a team of 3 needs to monitor 35 cameras simultaneously, all the while directing emergency services, all the while writing down incidents on paper. So we're completely automating that process with our system. We're not completely replacing the human operator. What we're allowing them to do is to be able to actually monitor all of these feeds simultaneously and replacing their paper process while simultaneously giving them the ability to automatically output that data to things like the digital highway signboards that say traffic moving slowly and so on and so forth. Sending out to a Twitter feed so that people can follow it and get real-time traffic updates. Output it to Google KML so they can reroute autonomous vehicles, and also output it on their actual incident dashboard here so that they can see at a glance the highway conditions from any camera along the highway.
That's really cool.
So do you guys have any questions about how it works or what it does?
Hey, so I have a question about how were you able to interface with the Ministry of Transportation?
So we did this all on our own steam. Basically, when we came up with the idea for the project, we started to get in contact with people at MTO as well as people in civil engineering at U of T because we knew that they had a provincial mandate for surveillance on the highway. So upon that initiative, they gave us funding to produce this storage array so that after we're done with it, they can also analyze the video footage for civil engineering.
And we should add that there's 100 terabytes.
There's 100 terabytes of data.
100 terabytes.
So we collect the video footage, we analyze it with our system, we produce aggregate statistics, and then their civil engineers can take it offline and use that information for checking highway safety parameters and performing infrastructure improvements throughout the region.
What did you say was the highway safety?
Sorry? So Lattice sits on the bottom screen. The letters. Oh, I see. So those three letter identifiers are just unique identifiers that we're tagging these vehicles. So what you're seeing on the screen here is actually just the processing backend. We've just sort of opened it up so that people can see inside and have a look at it. So that would not normally actually be used by the Ministry of Transportation. They would use the system. So this gives you an idea of what's actually happening underneath the sun. What you're seeing there is the traffic flow, you're seeing the vehicles being recognized, you're seeing the flag, you're seeing the traffic. Yeah, we're picking it up all live. Yeah, so I mean, this video's been running for a while, so there may be several incidents I can't go see, but this is all live, this is not pre-recorded. So it's analyzing the video in real time, then it creates an incident reconstruction. That's the video incident replay. So actually, what the video that you're seeing is the incident reconstruction. We've tracked the vehicles or the location of the incident as it moves through the field of view. John, could you maybe show them one of the incident reconstructions? Right there. Oh, is it showing right now? Okay. That's an incident reconstruction. It's a replay that tracks the vehicles as they go through the scene. So obviously we didn't show you guys a gory crash with mangled vehicles because obviously we don't want to show you. But the system has the capability of tracking these types of things. And what it means is that it can direct emergency services faster because those incidents can be seen and classified and reported on before even the operators see them. Because usually what's happening right now, as you can see on the center screen, there's a very low probability that operators, when they're managing 35 screens simultaneously, and on the phone, and on the radio, and writing logs, that they can notice these things when they're happening. So we let the system do it. The system reports on it, and the system has the capability of notifying people.
So we're counting the number of vehicles going this way and that way per frame, and then we're also we also track incidents that occur in the video.
Yeah, go ahead. useful, and that's got a lot of people grabbing them.
So basically, you'll actually see an incident show up along in this video because we have it playing. But an incident actually occurs where a vehicle stops right here, and we actually detect it, and then we alert our operations center that an incident has occurred. We create an incident, we reconstruct the incident, give them a clip that is marked up to show what the incident, where the incident is, so the operator can then determine the best course of action to do and classify it for storage purposes. So, it'll take a few more seconds, but the operator would not actually be seeing any of this stuff. The operator of the MCO headquarters would be over there looking at the website, and would just be seeing full statistics of each camera, and also any instance that occurs automatically notifies the website, the operations center, and they get
Major avenues because there's no traffic cameras on it.
Well, email ideas are just kind of
Video fees, okay.
So these are like, let me just use one of the cameras so you can see them here.
And those are the MTO cameras, right? Yeah.
These are all the cameras that MTO operates, and those are the cameras we work with. Because that's what we have access to. So if some other private company had cameras as well, and they said, here's the access to the data, and of course we would do those. So you can actually, one thing that's cool is you can actually search for a specific camera. We have Google Maps and things. So for example, you want to see the camera at Eglinton, submit. Okay, well let's look at the highway here. What's that look like? There you go. So you can integrate right with Google Maps.
So it's great. Once it's finished processing, which is going to be a few more seconds. So then you get notified very quickly that an incident has occurred and actually call emergency services or
Just take like hundreds of pictures.
for this one, they don't really need to call.
So you guys are electrical? I know Andy is
software.
software.
Yeah, the three of us.
What was the? I was just
If we were electrical, we'd be talking about how this is like signal processing.
Yeah.
But
then I
it is
realized.
a processing. It is a processing. It's a signal processing pipeline. That's what it is.
And you're relaying over the video to trace the software that you've created.
Yeah, so we use artificial intelligence to track objects within the video sequence.
Okay. What was the amount of contribution by open source software?
A lot.
This
Very
entire
large.
project is open source.
Okay.
We've open sourced the entire project.
It's GPL license.
It's GPL license. So technically, what is it? Copy left or copy right?
Copy left.
Yeah, so it's copy left. But we have all the intellectual properties for this. We engineered this system from the ground up.
Nice. Awesome. It's a great project.